Okay, we're going to finish up in notes by looking at a special type of compound event, the successive event. Whereas the other ones we've taken notes on can happen at the same time, like you're drawing one marble, or you're looking at one person and one vote. A successive event is talking about events that occur one after the other, right? And this now, and it could be independent or it can be dependent, right? Because if one event happens, sometimes it has an effect on how the second event will occur. Okay, if it does have an effect, it's called dependent, which is normally what happens. But if it's very lucky, then the events do not have any effect on each other, and they're called independent events. And they each have their own formula to find an and probability. For the independent events, all you have to do is just multiply the two probabilities together. But if it's dependent, you have to adjust the second one given what happened with A. Okay? So this formula would read the probability that they both happen in succession is the probability the first one happens times the probability the second one happens given the first one occurred. And we'll be able to figure that out just by studying the example and figuring out how the probability is going to shift. Notice that the only difference in the formulas is it probability of B or is it probability given what A happened? Okay? So, for examples, if you're rolling a die and then you select a tile from a bag, is that independent or dependent? Well, the die has nothing to do with the bag, so these are independent events. They do not affect each other. What's the probability that you are even and you're going to draw an M? Well, the formula says all you have to do for that and is to just do the probability of the event happening. Oops, I meant to say even. The probability that you roll an even times the probability that you pick an M. So the even chance is a half, and the chance you draw an M out of those 6 letters is 2 out of 6. So 2 out of 12 is 1 out of 6. Okay? Different example. Let's say you have a bag of marbles with 3 colors. You pick a marble without replacing it. So you pick it and you keep it in your hand, and then you go in to pick another marble. Are these dependent or independent? Well, the bag of marbles changes on every draw, right? Because if you're taking one, you're not putting it back. There's a different, the probabilities have shifted, right? Because there's different percentage of all the marbles in there, of all the colors. So this would be an example of a dependent event. And whenever you have something without replacement, it's dependent. So why is it dependent? Because when the first marble is removed, the pool or the marbles in the bag changes. So what's the probability you draw a blue one and then you draw a yellow one? So the formula says that it's the probability of drawing the blue one, that doesn't change, but times the probability you draw a yellow one. But there was a wrinkle in it, right? It was a dependent event. So it's not just the probability that you draw a yellow because it got affected. It's the probability that you draw a yellow given you draw a blue. This is given, that little vertical bar. So the probability that you're blue is pretty simple. It would just be, there's 20 marbles, so just be 5 out of 20. Okay? But if you keep that blue marble out and you go in to pick another marble, there's not 20 marbles in there, there's 19. And how many yellows are in there after you take out a blue? Still 9. So this is equal to 45 out of 380, which is around 12%. Okay? So dependent event calculations are a little tougher. But at the end of the day, it's still just multiplying events together. Okay? So let's say you have a deck of cards, you pick a card, but you do not replace it. That's a red flag. And then you go in to pick another card. Well, these are dependent because when you go in to pick another card, that card that you drew isn't there anymore. So the second pull is affected by the first. So what's the probability that you do the ace of clubs and that card looks like this? It's a black card. And there's only one of them in the whole 52. So what's the chance that you select that and then you pick a heart after that? So there's only one card like that in all the 52 cards. So the probability of hitting that ace of clubs is really 1 out of 52. So super slim. 2% chance. And we said that when we go pick the second card, it's affected by the first. So the probability that you draw a heart is one thing, but since you're not replacing the card, there was an effect. They're dependent. So you have to say, probably draw a heart given that you drew that ace of clubs. So if you pull out that card, how many cards are in your deck now? 51. And how many of those are hearts? Remember that there's 13 of each suit. We got your diamond, your heart, your spade, and your club. So when you take out a club, the ace of clubs, you still have 13 hearts, right? So this would be the answer, okay? And this boils down to around 0.5%. Okay, but you would multiply these together. Okay, one more. So Miss Smith's class has 13 boys and 17 girls. She calls on one random student to answer the question. They answer it. And then Miss Smith calls on a different random student for a question. Okay. So are these independent or dependent events? Did one occur without the effect of the other? The answer to that is no, because she picked on a different student. Right? So these would also be dependent events. Okay. What's the chance that she calls on a girl and then another girl? Well, that would be the probability you pick on a girl times the probability you get another girl. But it doesn't end there, because this probability that you pick a girl is different than the first one, because the first one you got 30 people, but then the next one you only had 29. So this is the probability you pick a girl given you picked a girl to start with. So you'll see that the first probability is simply just 17 out of 30. But this one is going to be, let's see, how many girls are left after you remove a girl from the set? There's only 16 left. And there's only 29 classmates left. So this is equal to 136 for 35, which is about 31%. Okay? So if the events are independent, they do not have effect on each other, and you just multiply their probabilities. But if they're dependent, you have to do the work and figure out what is that affected probability.